right, so skipping to the next smallest planet from Mercury, it would be Mars. So Mars, although we kind of think Mars is like a sister planet to the Earth, and I'll tell you reasons why that might be, actually a better sister planet probably would be the planet Venus, because Venus and the Earth are more similar in size. Mars is a fair bit smaller, and then as you know, that's why it cooled off more quickly. Mars is located about 1.5 astronomical units from the Sun. Remember what an AU is it's the average distance between the Earth and the Sun. This is where Mars is similar to the Earth. Actually, it's tilted. Its tilt is very similar to ours, which remember is 23.5 degrees. The Earth's axis of rotation is tilted. And Mars spins on its axis, its tilted axis, and it completes one rotation in about 24 hours. So that's similar to the Earth. The Martian atmosphere is relatively thin. It's thinner now than it used to be, and we'll talk about why that is. The composition of Mars' atmosphere is mostly carbon dioxide. And because it's so thin, really there's not many gas molecules to act as a blanket, so it has a very little greenhouse effect. So, like I said, the biggest difference between Mars and the Earth would be Mars is a fair bit smaller. So this is depicting Mars orbiting the Sun, and you can see Mars' axis of rotation tilted. And as it turns out, because of its tilt and perihelion and aphelion, actually the southern hemisphere has more exaggerated seasons than the northern hemisphere. One of the things that we can see here from Earth when we look at the planet Mars is a little bit of an ice cap near the poles. And the season that's experiencing winter time, like this over here, you can kind of see the northern hemisphere is experiencing winter time over here. That we actually can see more white cap up there near the poles. Now that white cap is not water ice; it's actually carbon dioxide ice. So Mars has its seasons just like the Earth has its seasons. And so long ago, actually, related to it spinning on its axis every 24 hours and it having kind of, we could see seasons because we could see those, what we thought were ice caps kind of during the winter expand and during that hemisphere summer kind of get smaller. You know, maybe years ago we thought there was maybe potentially life on Mars. So that leads me to this sort of interesting thing. If you're familiar with the H.G. Wells book, War of the Worlds, Orson Welles, which is a thespian, back in, I think it was the 1930s, he actually did a dramatization of that War of the Worlds over the radio. And back then, in a given evening, folks would kind of gather around the radio and listen to this ongoing radio theater. And so at the beginning of the radio theater, you know, they explained that this was just a dramatization. But the way the drama unfolded, you know, how they presented their narration was that actually Earth was being invaded by aliens from Mars. So people would tune into the radio broadcast and it would sound like it's a real thing. And so there was a panic, and honestly, it sounded pretty extreme where people thought that Earth was really being invaded by Martians. So anyway, here are those caps I was talking about, these polar caps. Remember that these are carbon dioxide, not water. But another feature on the surface of Mars that we can see, actually, depending upon Mars' location to Earth, are these dust storms in the Martian atmosphere. So kind of you can see, you know, just a matter of a few months within the same year, June to September, how different the surface of Mars looks because of these dust storms. So another feature of the surface of Mars we see kind of these, it's kind of seeing the snake-like pattern that looks like a kind of a meandering river. Okay, so there are definitely, going back to the meandering river thing, there are definitely features on the surface of Mars that looks like there used to be running water. And here we see kind of eroded craters. The craters, if you remember back to the craters on Mercury, the planet Mercury, and the craters on the moon, they're nice and crisp. And they've been kind of preserved over time. These craters here on Mars looks like they've had some sort of erosion going on, and this is probably kind of like maybe wind erosion eroding these. Let me go back one slide. All right, so fall 2012, Curiosity is sending back pictures now. Curiosity is a relatively new rover on the planet Mars, and we have seen, I think this might be the third time I've mentioned it, but Curiosity has sent us back pictures now where you can see kind of like little pebbles that you would see at the bottom of a stream bed. So we definitely know that there was running water on Mars. A few slides coming up, I need to explain, well, what happened to this hydrological water cycle. Where is the water cycle now? Well, this is kind of a map of various aspects of the surface features of Mars. I'm going to kind of point a few things out coming up. I would mention that NASA has an awesome, NASA has great websites, including their websites for Mars, so you can almost feel like you're there. So some important features on Mars. This one is Olympus Mons, kind of over here. This is a photograph of Olympus Mons. Now, it's not an active volcano per se right now, but it's a humongous volcano about the size of, I think, Arkansas, okay, the state of Arkansas. Olympus Mons is just humongous, and it was created, they think, by what we call just one hotspot volcanism. So it's not our usual kind of like volcano here we see on our planet. Another feature I want you to know, and I think this did make it to the test, is this region called Valles Marineris, and I might be butchering the pronunciation of that, but it is a we saw a picture of the Grand Canyon on Earth, and I've not visited the Grand Canyon. The Grand Canyon was formed by, we said, the erosion of running water. But Valles Marineris actually would stretch from North America, our east coast, to our west coast. That's how long this crazy canyon is. And it wasn't formed by running water. It was formed actually as the planet Mars was cooling. So this Valles Marineris is kind of in the equator region. Okay. I haven't updated this slide yet, but I mentioned Curiosity is a new rover on Mars. There were two rovers that kind of went up kind of back to back, Opportunity and Spirit, that preceded Opportunity. And, Opportunity and Spirit that preceded Curiosity. And actually Spirit, I don't know how long ago, but Spirit actually is not functioning anymore. I think it got stuck in the terrain of the planet Mars and just couldn't get out. But Opportunity is still sending back pictures, I believe. So these are a series of pictures kind of getting closer and closer up at a region of Mars that to kind of look for evidence of running water. So it's just amazing. This, to me, those rocks just look like maybe you're here on Earth. Now remember we said in an earlier segment in this chapter, we said that the Earth's skies are blue because of Rayleigh scattering of the nitrogen gas particles in the Earth's atmosphere scatter blue light. Well, you can see that the Martian skies are kind of take on a different color. Well, the composition of the Mars atmosphere is different, isn't it? All right. So there is water on Mars, but we believe that most of the water right now is frozen. We say that, and yet you can kind of see where This is kind of like a little gully that was formed by liquid water, and not that long ago. If I understand it correctly, I think even since rovers have been roving around, remember opportunity and spirit and now curiosity, we're looking for signs of modern day liquid water kind of, how do I say, running in small areas like this. So if Mars used to have running water, water, basically a hydrological cycle. Remember, well, here on Earth we call it the hydrological cycle when water vapor condenses into clouds, and from the clouds we have rain or precipitation, and then that precipitation evaporates back up, and that's called the hydrological cycle. So what's up with Mars? Okay, well, this is an early picture of Mars, where if you notice, these pink lines are the pink lines we had before showing Earth's magnetosphere, or Earth's magnetic field. Okay. Now remember, in order to have a magnetic field, you need to have some sort of ooey gooey or liquid in your core, and the planet needs to be spinning. So we believe that before it cooled down, Mars did have a magnetic field. But now that only lasted for about the first 1.5 billion years or so. Ever since then, so that would be about 3 billion years to date, actually its magnetic field went away, and the reason its magnetic field went away was because its core solidified. So notice the difference here from left to right. Mars today has no magnetic field, and so when this yellow here this is solar wind blowing in all directions, including the direction of Mars. So the solar wind basically blew when it had no magnetic field. Then the Martian atmosphere was susceptible to solar wind. It could just be kind of swept away. I kind of imagine the region then downwind or down space actually then kind of got the Mars early atmosphere. Okay, so with no atmosphere, then it lost its, among other things, its ability to stay warm, the greenhouse gases. Okay, so we believe that that is how Mars lost the majority of its atmosphere. I think that's a homework question. Okay. So this just kind of finishes that thought.